Okay, so students, we shall start the class. So 8 o'clock. So students, we shall. So let me share the screen. Okay, so can you say hi to me? Okay, so say good night to madam. Okay, so we shall start the class. Okay, good. So tonight, okay, so since some of you just gone through the dehydrations of alcohol mechanism, so I let you practice and get familiar with the dehydrations of alcohol mechanism first, okay? So tonight I'm not going to do mechanism, so Saturday only we do the mechanism. Tonight we just focus on the chemical reactions of alkene. Okay, so for alkene, so we know that the functional group is, okay, okay, so we know that alkene, the functional group is carbon-carbon. Okay, so it's a carbon-carbon double bond. So carbon-carbon double bond, we know that it is electron rich. So this carbon-carbon double bond is electron rich. So when it is electron rich, it will be attacked by, so it will be attacked by the electrophile. Okay, so carbon-carbon double bond electron rich, so it will be attacked by the electrophile. Okay, so therefore the chemical reaction that alkene can undergo basically is electrophilic addition. Okay, so electrophilic addition. And tonight we are going to look at electrophilic additions reaction. Okay, so alkene, so the functional group carbon-carbon double bond. So because it is carbon-carbon double bond, so it is electron rich. So during the reaction, the carbon-carbon double bond can be broken, okay, into two single bond. Okay, so that's why it is addition type of reaction. Double bond become single bond. So addition type of reaction. Okay, and then one product will be obtained at the end of the reaction, and the product will be the saturated organic compound. Okay, will be saturated organic compound. So, and then for electrophilic addition, okay, so of alkene, basically it will follow Markovnikov's rules. So tonight we are going to look at the Markovnikov's rules. Okay, so for Markovnikov rules, for additions of alkene, so if we are adding HX into the alkene, so the hydrogen atom is going to be added to the carbon of the double bond with greater number of hydrogen. So what does this mean? So basically it means that, so if we have alkene, so this is the alkene. When it reacts with HX, okay, so the hydrogen of the HX, it will go to the carbon of the carbon-carbon double bond, which has greater number of hydrogen atoms. So which of these two carbon of the carbon-carbon double bond has greater number of hydrogen? So this carbon has two, and this only have satu hydrogen directly attached to it. So means that this carbon, the first carbon here, has more hydrogen. So means that the hydrogen of the HX will go to the first carbon here. So, okay, remember additions reaction, double bond will become single bond and the H will go here. Okay, and then the X will go to, okay, so this is according to Markovnikov's rules. So with that in mind, then now, okay, so we shall move on to look at the electrophilic addition. So again, alkene, carbon-carbon double bond, electron rich, so will be attacked by the electrophile. So this is the electrophile. Okay, and then after the electrophile added into the alkene, it will become single bond. Okay, so this one both are hydrogen, so means that one will go to this carbon and another one will go to this carbon. So to give you saturated products. Okay, so here our electrophile is hydrogen. Therefore, the name of the reaction is hydrogenation because the electrophile is the hydrogen. Okay, so and then for hydrogenation required the presence of catalyst, palladium, platinum or nickel, okay, to do the hydrogenation reaction. But it is still electrophilic addition type of reaction. But then the electrophile now is hydrogen. That's why the name of the reaction is hydrogenation. So now we move on to look at the example. So look at the example 1. So this is alkene. So alkene undergo addition type of reaction. So what does it mean? So double bond. So double bond becomes single bond. So double bond becomes single bond with, so this is the electrophile HH. So each of the hydrogen go to each side. Hydrogenation. Okay, so the second example, so this is our alkene. So alkene undergo addition type of reaction. So double bond becomes single bond. Double bond becomes single bond. Okay, so how to draw the product? So double bond becomes single bond. Okay, so double bond becomes single bond. And then our electrophile hydrogen. So setiap hydrogen ini go to each of the single bond. So this is the product of hydrogenation. So then we move on to look at halogenation. So just now we have looked at hydrogenation. Hydrogenation, electrophile is the hydrogen. In halogenation, the electrophile will be the halogen. And this halogen can be chlorine or bromine. And halogenation can be conducted in inert solvent or in water. So for inert solvent and water will give you different products. Okay, so inert solvent means that this solvent will not affect the product. Inert solvent will not affect the product. Okay, so example of inert solvent that we can use in the halogenation reaction is dichloromethane, CH2Cl2, or chloroform. Okay, so these are the common inert solvent that we use to do halogenation. Okay, so again, this is addition, electrophilic addition type of reaction. So addition means that double bond become single bond. You see, double bond becomes single bond. Okay, and this is your halogen. So this halogen can be Cl2 or Br2. And this is inert solvent. So inert solvent will not affect the product, So the electrophile will each go to each side of the carbon-carbon double bond. Okay, so for halogenations in aqueous solution, so aqueous means that the solvent is water. So water will affect the product. Okay, so water will affect the product. Okay, so how to predict the product? So later on we are going to look at it. It's also based on Markovnikov rules. Okay, Markovnikov's rules. So now we move on to look at the example of halogenation in inert solvent first. So halogenation in inert solution. So again, this is called halogenation because the electrophile that we use is halogen. Okay, so this is inert solvent. Okay, so again, this is alkene, carbon-carbon double bond, undergo addition type of reaction. So kalau addition type of reaction means that the double bond will become single bond. Okay, so this is our electrophile in the inert solvent. So inert solvent will not affect the product. So the electrophile will go each side of the, okay. So now we move on to look at the second example. So still alkene, carbon-carbon double bond. So undergo addition type of reaction. So kalau addition type of reaction, then the double bond will become single bond. Okay, and the electrophile chlorine in the inert solvent won't affect the product. So the chlorine will go to each side of the carbon-carbon double bond. Okay, so this is halogenation in inert solvent. So how about halogenation in aqueous solution? So for halogenations in aqueous solution, okay, so the halogen will go to, carbon of the carbon-carbon double bond, which has greater number of hydrogen. Follow the Markovnikov rules. So the halogen atom will go to carbon, which has more number of hydrogen atoms. Okay, according to Markovnikov's rules. So halogen will go to carbon with more number of hydrogen. So let me give you an example. Okay, so again, this is alkene. So undergo addition type of reaction. So carbon-carbon double bond become single bond. So where should be the Br? So one Br will go to, according to Markovnikov's rule, go to carbon atom of the carbon-carbon double bond with more number of hydrogen. So which one has more number of hydrogen? So the first carbon here. So means that your Br must go here. So actually, after your Br go here, this carbon will have 3 bonds. So if 3 bonds, it will become positively charged. And then now the solvent is water. So water, we know that this is partially positive, this is partially negative. So the partially negative side water will go to this carbon, Therefore, OH will come in like this. So this is the product if we conduct the halogenation in aqueous solution. Okay, so the solvent water will affect the product. Okay, and according to Markovnikov rules, bromine or chlorine, the halogen, need to go to the carbon of the carbon-carbon double bond, which has greater number of hydrogen atoms. So we move on to look at more examples. So aqueous means that the solvent is water. Okay, so again, this is alkene. Alkene, carbon-carbon double bond, will undergo addition type of reaction. So means that the carbon-carbon double bond will become single bond. Okay, and the halogen atom, one atom, will go to the carbon that has more hydrogen. Kat sini, carbon ini tidak ada ikat kepada hydrogen directly. Okay, but this one has two. Okay, so the Br will go here. Lepas Br masuk, this carbon, can you see 3 covalent bond? So it is positively charged. So the solvent water, the partially negative charge side will go in. So this is your product. Be careful not to write as HO. Salah. The carbon will be bonded to oxygen. Sebab oxygen, that is partially negative. Okay, and then only the hydrogen. So now we move on to look at another example. So still alkene. Alkene undergo what type of reaction? Addition. So what is addition? So double bond becomes single bond. Double bond becomes single bond. So double bond becomes single bond. Okay, so your chlorine need to go to carbon that has more hydrogen. So can you see that this carbon already has 4 covalent bond, no hydrogen. But this carbon has 1, 2, 3, so means that 1 hydrogen. So this carbon here has more hydrogen, so means that Cl need to come here. Okay, and then the aqueous, so means that solvent is water. Solvent is water. So remember, after Cl coming, this carbon will become positively charged, 3 bond. So therefore, partially negative side of water, OH, will come in. So this is the halogenations in aqueous solutions product. Okay, so I have gone through two electrophilic addition, hydrogenation and halogenation. And halogenation can be in the inert solvent. So inert solvent, kedua-dua halogen will be added, atom will be added into the carbon that involved in carbon-carbon double bond. Okay, but if in aqueous solution, only one halogen atom will go to the carbon which has more hydrogen. Another one will be the OH that added in. So then we move on to look at hydrohalogenation. So hydrohalogenation, okay, so we move on to look at hydrohalogenation. So hydrohalogenation, okay, so follow Markovnikov rules. So if the reagent is HBr or HCl, so it will follow the Markovnikov rules where hydrogen atom will go to the carbon which has more hydrogen, and the X will go to the carbon that has less hydrogen. Okay, so if HBr with the presence of peroxide, so this is peroxide, then it will follow anti-Markovnikov rules. Kenapa? Because this is no longer electrophilic addition. So sebenarnya this is free radical addition. But the mechanism of it, you don't need to know. It's not in the syllabus. So it is because it is a free radical addition. That's why it is anti-Markovnikov rules. So we will look at this in details. Okay, but then the condition is the reagent is HBr with the presence of peroxide, then it will be anti-Markovnikov rules. Okay, if no peroxide is only HBr or HCl, then follow Markovnikov rules where hydrogen ditambah ke carbon of the carbon-carbon double bond, which has more hydrogen to start with. Okay, so and this HBr or HCl addition is called hydrohalogenation reaction. So why called hydrohalogenation? Because you add your electrophile sekarang, your electrophile is basically hydrogen and halogen, HX. Okay, that's why this addition reaction dipanggil hydrohalogenation reaction. Because your electrophile now is HX. So now we move on to look at hydrohalogenation that follows the Markovnikov rules. So again, so for addition reaction, if adding HX, so if adding HX, oh, I forgot to okay, so I forgot to make a corrections for this. So if the alkene is unsymmetrical, so the, okay, never mind. So the hydrogen atom of HX, so the hydrogen atom, okay, so the hydrogen atom is added to the carbon of the carbon-carbon double bond, which has greater number of hydrogen atoms. Okay, so if we are adding, so adding HX into alkene, so follow Markovnikov rules, hydrogen atom of the HX must go to the carbon atom, which has greater number of hydrogen atoms. Okay, that is Markovnikov rules. So for example, okay, madam forgot to, okay, can you change this to HCl and this HBr? Okay, so can you see that this one is again, so follow Markovnikov rules. Okay, so follow Markovnikov rules. Okay, and then here is our alkene. So again, alkene undergo addition type of reaction. So alkene undergo addition type of reaction. So kalau addition, so the double bond become single bond. Double bond become single bond. So now the must follow the Markovnikov rules because there is no peroxide. Okay, so hydrogen need to go to the carbon which has more hydrogen. So between these two carbon, which one has more hydrogen? Can you see that this carbon has two? This only have one. So this is two, this is one. So means that this carbon has more hydrogen to start with. So according to Markovnikov rules, the hydrogen of your HX will go to the carbon which has more hydrogen. So which is this carbon. And the Cl will go to here. Okay. And then in example 2, also no peroxide, so follow Markovnikov rules. No peroxide, follow Markovnikov rules. Okay. So, and then this is alkene. This is alkene. So alkene undergo addition type of reaction. So what is addition reaction? So remember the double bond become single bond. Okay, and then according to the Markovnikov's rules. So what Markovnikov said, the hydrogen must go to the carbon which has more hydrogen to start with. So this carbon has one hydrogen here. This carbon, there is no hydrogen directly attached to it. There is no hydrogen directly attached to it, so 0. Okay, so which one has more? This third carbon, so means that hydrogen need to go to the third carbon and the Br need to go to the second carbon. Okay, so this is according to Markovnikov's rule. Then we move on to look at if there is a presence of peroxide, then we need to follow Markovnikov rules. Okay, so if there is the presence of peroxide, so example of peroxide, it can be CH3, OOCH3, or it can be H2O2. Okay, not necessarily CH3, it can be a very big group. Usually we just write it as ROOR. And this R can be referring to any alkyl group. Okay, any alkyl group. So as long as you see the two O come together, or H2O2, so these are peroxide. So if peroxide, then there is a presence of peroxide, then need to follow the anti-Markovnikov's rule. So anti-Markovnikov's rule basically said that it's opposite to Markovnikov rules. Opposite to Markovnikov rules. Okay, so when we add the HBr, so when we add HBr with the presence of peroxide, then the hydrogen atom of the HBr will go to the carbon with fewer number of hydrogen atoms. So opposite to Markovnikov rules. Okay, opposite to Markovnikov rules. Okay, so for the anti-Markovnikov rules, so we can only use HBr with the presence of peroxide. HBr with the presence of peroxide, and the hydrogen of the HBr must go to the carbon that has fewer number of hydrogen atoms. Okay, so shall we look at the example? So can you see that this one peroxide, this one peroxide, this is hydrogen peroxide. So if you see peroxide, then it must be following anti-Markovnikov rules, where the hydrogen will be added to the carbon of the carbon-carbon double bond, which has fewer number of hydrogen. So again, this is carbon-carbon double bond. So the first carbon has 2 hydrogen, so 2 hydrogen. And the second carbon only have 1 hydrogen. So this one has peroxide. So means that it need to follow anti-Markovnikov rules. So what should be the product? Again, carbon-carbon double bond undergo addition type of reaction where double bond become single bond, okay, and number other peroxide, so need to follow anti-Markovnikov rules. So the hydrogen need to go to carbon which has fewer number of hydrogen. So this carbon, fewer number of hydrogen, and the Br here. Okay, so now we move on to look at example 2. So example 2, again, is still alkene, carbon-carbon double bond. So undergo addition type of reaction. So where carbon-carbon double bond will become single bond. So this one with the presence of peroxide. So follow anti-Markovnikov rules. So anti-Markovnikov said that hydrogen need to go to carbon yang kurang hydrogen. So this carbon, the other hydrogen, 0 hydrogen attached to it. This carbon has 2 hydrogen. So this carbon 0. So kurang, according to anti-Markovnikov rules, hydrogen of the HBr need to go to carbon yang kurang hydrogen. Okay, and the Br here. Okay, so you just need to see presence of added to carbon yang kurang hydrogen. Okay, so that is the third additions reaction. So we have seen hydrogenation, halogenation, and hydrohalogenation. So, another example. So this one, nampak peroxide. So follow anti-Markovnikov's rule. Follow anti-Markovnikov's rule. So still, this is alkene, undergo additions reaction. So if additions reaction, double bond becomes single bond. Double bond becomes single bond. So no hydrogen. So 1, 2, 3, 4, 4 bonds there. So no hydrogen. So for this one, 1, 2, 3. So 1 for hydrogen. So this one 0 hydrogen. This one 1 hydrogen. So this carbon kurang hydrogen. So the hydrogen will go to this carbon and the Br will go to this carbon. Okay, we follow anti-Markovnikov rules because there is a presence of peroxide. So the fourth electrophilic additions reaction is hydration. So hydration is called hydration because now the electrophile is water. Okay, so water. So that's why the name of the reaction is called hydration. So it's still the same. So follow Markovnikov rules. Hydration also follow Markovnikov's rule. So we know that now our electrophile is water. So follow Markovnikov rules. Hydrogen of the water will go to the carbon which has more hydrogen. Hydroxide go to the carbon that has less hydrogen. Okay, and then require the presence of the catalyst. Okay, require the presence of catalyst. So basically acid. So hydration. So still this is alkene, carbon-carbon double bond. Carbon-carbon double bond undergo addition type of reaction. So double bond become single bond. Okay, now our electrophile is water rules according to Markovnikov rules. Okay, so Markovnikov kata apa? Hydrogen need to go to carbon of the carbon-carbon double bond yang mempunyai lebih banyak hydrogen. So the first carbon here has 2 hydrogen. This one, the second carbon has 1 hydrogen. So the first carbon has more hydrogen. So the hydrogen of the water will go to the first carbon. And the OH go to the second carbon. Okay, so now we move on to look at example 2. So example 2, still alkene, undergo addition type of reaction. So undergo addition type of reaction. So if undergo addition type of reaction, carbon-carbon double bond will become single bond. And then follow Markovnikov's rule. Follow Markovnikov's rules. Hydrogen need to go to the carbon that has more hydrogen. So carbon pertama ini has 2 hydrogen. Carbon kedua, no, 0 hydrogen. So which one has more hydrogen? The first carbon. So the hydrogen of the water must go to the first carbon. And the OH go to another carbon. So that is hydration. So another example. So another example, so this is still alkene, undergo addition type of reaction. So addition type of reaction bermaksud double bond become single bond. Okay, become single bond. So this is water. According to Markovnikov's rule, hydrogen of the water need to go to the carbon yang mempunyai lebih banyak hydrogen. So this carbon 1, 2, 3, 4 tak ada untuk hydrogen dah, zero hydrogen. So this one 1, 2, 3, 1 hydrogen. So 1 hydrogen. So this carbon 1 hydrogen. So it has more hydrogen. So hydrogen need to go here. Okay. So the hydrogen of water need to go here and the OH need to go here. 2 hydrogen. Ini satu and satu from the water. So you have 2 actually. Okay. So that is hydration. So we have seen 4 electrophilic addition type of reaction. So the first one, hydrogenation. Second, halogenation. The third one, hydrohalogenation. And the fourth one is hydration. So mechanism, so I told you already, tonight we don't want to do mechanism first because not fair for some of the classes. They haven't gone through the mechanism for dehydrations of alcohol. Some baru belajar. So I let you learn more first. Okay, then Saturday only we look at the hydration and also hydrohalogenation's mechanism. So just now we have seen alkene can undergo electrophilic additions type of reaction. So selain daripada electrophilic addition type of reaction, alkene can also undergo oxidative cleavage. Can also undergo oxidative cleavage. So what does cleavage mean? Cleavage means bond breaking. Bond breaking. Okay, so means that alkene carbon-carbon double bond after undergo oxidative cleavage. So basically double bond break. Double bond break. Okay, double bond break begini. And then oxidative cleavage. Oxidative bermaksud it will gain oxygen dekat sini. What meant by oxidative cleavage? You break the carbon-carbon double bond and then they will get oxygen. So whether you get carbonyl or carboxylic acid as your product, it depends on the reagent that you use. Okay, so shall we have a look in detail? So again, alkene reaction kedua, the second type of reaction alkene can undergo is oxidative cleavage. Is oxidative cleavage. So for oxidative cleavage, okay, so there are two. So the first one is ozonolysis. Ozonolysis, basically the reagent that you use is ozone. So reaction ini berlaku 2 step. That's why you need to write 1. So the first step you guna ozone. The second step you need to use zinc water or dimethyl sulfide. Okay, so the reagent need to be added in 2 steps. Okay, so if you are being asked to give the reagent for ozonolysis, you also need to write 2 steps like this. You also need to write your reagent in 2 steps like this. Okay, so basically for ozonolysis, so ozonolysis is oxidative cleavage. So tadi Madam sudah jelaskan apa itu oxidative cleavage. So basically break the carbon-carbon double bond, you put in the oxygen. You put in the oxygen. So for ozonolysis, you will get carbonyl as your product, whether aldehyde or ketone. Okay, so the second reagent that you can use to do oxidative cleavage is hot acidified KMnO4. Is using hot acidified KMnO4 or you can use hot acidified potassium dichromate. Okay, so both can be used, and this is how you write the reagent. Yang ini tak ada satu dua, so means that it's just one step reaction. It's just one step reaction. So the triangle here represent hot, means that you need heating. And then acidified is represented by the hydrogen ion, okay, KMnO4. So if they ask you to give reagent, this is the reagent you need to give, okay. And then hot acidified KMnO4 is strong oxidizing agent. Strong oxidizing agent. So when strong oxidizing agent is being used, still the same, you will break the carbon-carbon double bond. You will break the carbon-carbon double bond. Okay, so after break the carbon-carbon double bond, so they will gain oxygen. They will gain oxygen, but be careful if you are having H here, so means that, so this one break, so you will get like this. So this is ketone, and this is aldehyde. This is aldehyde. For strong oxidizing agent such as KMnO4, oxidation reaction, it will further oxidize to give carboxylic acid. It will further oxidize the hydrogen here to give you carboxylic acid. That's why if hot acidified KMnO4 is being used in oxidative cleavage, the product that you can get is ketone and carboxylic acid, or you can get carbon dioxide and water. I will explain in detail. Okay, and this reaction, for time being, you need to remember, it will not stop at aldehyde. It will not stop at aldehyde. It will further oxidize to carboxylic acid. And we are going to see this in detail in the alcohol carbonyl chapters. Okay. So now shall we look at example? So oxidative cleavage using ozone, ozonolysis. So if ozone, so ozone is just a very mild oxidizing agent, not too strong. That's why you can get aldehyde. Okay, but strong oxidizing agent, you can't get aldehyde. Okay, so we will see more examples. So we look at the ozonolysis first. So ozonolysis, okay, so ozonolysis, you see ozone, so means that this carbon-carbon double bond is undergoing oxidative cleavage. Is undergoing oxidative cleavage. So means that break. So what do you get? So what do you get? So first you break them first. So you break. You break the carbon-carbon double bond. Like this. So this is oxidative cleavage. So this is oxidizing agent. So means that dia akan bagi oxygen to them. About example 2. In example 2, again you see ozone. So means that this carbon-carbon double bond mengalami oxidative cleavage. Oxidative cleavage. So cleavage means break. You break the carbon-carbon double bond. Okay, oxidative. After you break, you give them oxygen. So how do you draw this? So first, need to draw the carbon-carbon double bond break. So break. Must draw them break because ozone causes oxidative cleavage, causes the carbon-carbon double bond to break. And then ozone is oxidizing agent, bagi oxygen. So this is your product. They no longer connected, sudah break. Okay, and they don't share oxygen sama, so you need to draw 2 oxygen there. So this is the example for ozonolysis of your alkene. So now we move on to look at if use hot acidified KMnO4. So hot acidified KMnO4, so this is strong oxidizing agent. So still break the carbon-carbon double bond. So break the carbon-carbon double bond, you will get two of this. And then this is oxidizing agent. So give them oxygen. Okay, so this is carbonyl compound attached to carbon-carbon. So this is ketone. So if ketone, then okay. Ketone, okay. In example 2, so hot acidified KMnO4, strong oxidizing agent, still cause oxidative cleavage. Break the carbon-carbon double bond. So break it, you get this. So shall we break first? So break. This is oxidizing agent, will give them oxygen. Can you see that this is aldehyde? This is also aldehyde. How do I know this is aldehyde? Can you see this is H? This is aldehyde. This is aldehyde. This is not good. Strong oxidizing agent will not stop at aldehyde. It will further oxidize this hydrogen to carboxylic acid. Okay, so further oxidize to carboxylic acid. Cannot stop at aldehyde. Ketone, okay. Aldehyde, no. Then how about this? This one, we have OH attached to the same carbon of the carbonyl. This is not stable. And the whole compound will decompose. It will decompose to give you carbon dioxide and also water. Carbon dioxide and water. Okay, so this whole compound will decompose to give you carbon dioxide and water. Therefore, whenever you see terminal carbon-carbon double bond, so this is terminal carbon-carbon double bond. So what does terminal carbon-carbon double bond mean? So basically it means carbon double bond, carbon attached to 2 hydrogen. Okay, so this carbon of the carbon-carbon double bond attached to 2 hydrogen. So this is called terminal carbon-carbon double bond. So terminal carbon-carbon double bond when undergo oxidative cleavage with hot acidified KMnO4 will always give you carbon dioxide and water. Again, terminal carbon-carbon double bond where the carbon, then when undergo oxidative cleavage with hot acidified KMnO4, it will always give you carbon dioxide and water. Okay? And then if you get aldehyde with KMnO4, it will further oxidize to carboxylic acid. Okay? So now we move on to look at another example. So example 3. Still hot acidified KMnO4. Okay, still hot acidified KMnO4. So this hot acidified KMnO4, kalau nampak hot acidified KMnO4 dengan carbon-carbon double bond, means that it will do oxidative cleavage. It will do oxidative cleavage. Break the carbon-carbon double bond. So break the carbon-carbon double bond. So you must draw the carbon-carbon double bond break. So how? 1, 2, 3. Have I drawn? Okay, let me draw this. Okay, so 1, 2, 3, 4, 5. So 1, 2, 3, 4. Correct. Okay, so CH3, CH3. So this is oxidative cleavage. After break, they will give them oxygen. They will give them oxygen. Can you see that this side, this is ketone. This is ketone. So KMnO4 oxidized to ketone, okay, no problem. But this side, this is hydrogen. So means that this side is aldehyde. Remember, this is strong oxidizing agent. Cannot stop at aldehyde. It will further oxidize to give you carboxylic acid. It will further oxidize to give you carboxylic acid. Okay, so just need to remember ozone and also hot acidified KMnO4. What are they doing? Oxidative cleavage. Break the carbon-carbon double bond. Okay, so for hot acidified KMnO4, strong oxidizing agent, cannot stop at aldehyde. It will further oxidize to give you carboxylic acid. And if you are having terminal carbon-carbon double bond, terminal carbon-carbon double bond, it will further oxidize until it get carbon dioxide and water. Okay, so that is for oxidative cleavage. So basically, why we want to do oxidative cleavage reaction? So oxidative cleavage, so if we have an alkene, so sometimes we do not know where is the carbon-carbon double bond. So this oxidative cleavage can be used to determine the carbon-carbon double bond of an alkene. Okay, so like for example, in this question, okay, so we have one unknown alkene. We do not know what alkene is that. We only know that the general formula is C6H12. So if we want to draw out the isomer, there are too many isomers, too many. Which one? Okay, so how do we know? So we can deduce it from we can deduce the alkene from the product of oxidative cleavage. So in this question, the question say when the alkene C6, so C6H12 react with, so it's oxidized with concentrated hot acidified KMnO4. So we have KMnO4 acidified hot, okay, and then form propanoic acid and propanol. So propanoic acid, 3 carbon, so 3 carbon. Propanoic acid is carboxylic acid. Carboxylic acid, the functional group is carboxyl group. Okay, so this carbon already four bond, so no hydrogen. This carbon, 2 bond, 2 hydrogen. This carbon, 1 covalent bond, so 3 more for hydrogen. So this is the propanoic acid. And then another product is propanon. Propanon. So non, so means that is ketone. Ketone. So prop 3 carbon, ketone. So ketone carbonyl group, must be in the middle of the chain. So this carbon, one covalent bond, 3 more for hydrogen. So the second carbon, 1, 2, 3, 4, no for hydrogen. This one, 1 covalent bond, 3 more for hydrogen. So this is propanol. So from these two oxidative cleavage products, how can we deduce the alkene? How can we deduce? Okay, so here, so this is the ketone and also the carboxylic acid. Okay, so break, that's why oxygen being added here. Okay, so if we want to go back to the alkene, means that we can remove the oxygen and sambung balik the carbon-carbon double bond, then we get the alkene, betul tak? Okay, then we get the alkene. So with that concept in mind, then we can solve this question. So how to get back the alkene? So we just need to sambung balik the carbon-carbon double bond. So where should be the carbon-carbon double bond? It must be here. They're connected. It must be here. They're connected because this is the side where the carbon-carbon double bond break and then oxidize. Okay, so how can we connect them back? Okay, so shall we draw like this? So this is the propanoic acid. So ketone, I draw like this. The propanol, I draw like this. Remember, oxidative cleavage, we break the carbon-carbon double bond and then oxidize it. So now we want to sambung balik the carbon-carbon double bond. So kita remove the oxygen dulu, and then here we connect back. Okay, so shall I draw slightly closer? Okay, let me draw slightly closer. So just now like this, right? So this is after oxidative cleavage, you get the propanol and the propanoic acid. Okay, now we want to get back the alkene. So means that kita remove the oxygen dulu, then sambung balik. So this is the alkene. So this is the alkene, but be careful, not yet the alkene. Remember this one is propanoic acid. So propanoic acid is about strong oxidizing agent. So it will further oxidize the aldehyde menjadi carboxylic acid. So means that here must be the H of your alkene. Okay, so to repeat, how do we get back the alkene? We need to know where is the carbon-carbon double bond. So where is the carbon-carbon double bond connected? It must be the C double bond O here. Okay, and then to connect them back, you remove the oxygen and then sambung balik begini. And the OH, it must be from the H because this is strong oxidizing agent, oxidized to carboxylic acid. If not, it will just be H like this. Okay, so can you see this is your alkene? So this is the alkene, C6H12. Okay, which undergo oxidative cleavage to give you the propanoic acid and the propanol. So again, why we want to do oxidative cleavage is to determine the positions of carbon-carbon double bond in the alkene. So dari the oxidative cleavage product, propanoic acid and propanol, kita hanya perlu cari tempat form the carbon-carbon double bond. So where? It must be the C double bond O, C double bond O. Remove the oxygen, sambung balik the carbon-carbon double bond, okay, to get the alkene. So I already covered the two type of reaction alkene can undergo. The first one, electrophilic addition, di mana double bond becomes single bond. Second is oxidative cleavage, di mana double bond break and then debury the oxygen. Oxidize, after break the carbon-carbon double bond, it is being oxidized. Okay, it is being oxidized. So, and then now we move on to look at unsaturation test. So what is unsaturation test? So we know that alkene has carbon-carbon double bond. So alkene has carbon-carbon double bond. So this carbon-carbon double bond means that alkene is unsaturated. So this unsaturation test basically is to detect the presence of alkene, presence of the carbon-carbon double bond. Okay, and then also to differentiate alkene from other classes of compound. Okay, because alkene ada carbon-carbon double bond. Other class of compound like alcohol, tak ada. Alkane, tak ada. So this unsaturation test therefore can be used to distinguish alkene from other classes of compound. So how many unsaturation tests we can do? So there are three. So the first one, Bayer test. So Bayer test. So the second, bromine test, and the third one is the test with bromine water. Okay, so and the third one is a test with bromine water. So Bayer's test. Will you please make a correction because the scientist is Bayer, so Bayer's test. Okay, so for Bayer's test, the reagent that used is KMnO4, but then now it's in alkaline condition. So this is alkaline condition, and you do it in cold condition. So kalau cold condition, it is not that extreme. It is not that harsh. So if not that harsh, so what is happening basically is addition. So carbon-carbon double bond, it will break. Become single bond. For this reagent, basically what is being added into the carbon-carbon double bond is OH. So this is what you learn in Form 5. You get diol. And this KMnO4 is purple in color. So after has reacted with alkene, so this purple color of KMnO4 will be decolorized. So that is the observation. So the purple color of KMnO4 decolorizes. Okay, and then you will also get MnO2. So this is manganese 4 oxide. So this manganese 4 oxide is brown precipitate. So you will see brown precipitate form. Brown precipitate of manganese 4 oxide form. So this is the observations for Bayer's test. Okay, so only alkene because mempunyai unsaturation carbon-carbon double bond, so it can cause the KMnO4 to basically added into the carbon-carbon double bond to give you diol, and then causes the purple color of KMnO4 decolorizes. Okay, so the alkene oxidized and the KMnO4 be reduced to manganese 4 oxide, and that manganese 4 oxide is brown precipitate. Okay, then now we move on to look at bromine test. So bromine test, basically we are using bromine in inert solvent. So what is happening is basically electrophilic additions reaction. So carbon-carbon double bond will break, become single bond. This is the electrophile. So electrophile, this is inert solvent, won't affect the product. So each of the atom of the electrophile will be added into each of the carbon. Okay, Br2 is reddish brown in color. Br2 is reddish brown in color. Okay, after Br2 pecah to and then being added into the carbon double bond, it is no longer Br2. Tengok, it's no longer Br2. Therefore, so Br2 is reddish brown color, but here is no longer Br2. So therefore, what you will observe is the reddish brown color of bromine. Br2 decolorizes. Okay, so then the third test, the third unsaturation test is test with bromine water. Means that the reagent that we use is bromine, and then the solvent is water. The solvent is water. Remember, water will affect the product. Okay, but this is still alkene, so it's still electrophilic additions type of reaction. So double bond become single bond. Double bond becomes single bond. Remember, this is water. Water will affect the product. Water will affect the product. So how would the additions product be? Okay, so follow Markovnikov's rule. Markovnikov kata apa? So the Br atom, so one Br atom will be added to the carbon which has more hydrogen. So this first carbon has 2 hydrogen. This one, 0 hydrogen. So which one has more hydrogen? The first carbon, so Br will come here. So after Br added it, so the second carbon actually will become positively charged. Therefore, the partially negative side of water will be added here. So this is the product of the Br2 in water added into alkene. Okay, so and then what is the observation? So what is the observation? So actually for this reaction, the byproduct will be HBr, because here one H and one Br remain. So the byproduct is HBr. If asked to write the equation, you can write the HBr. Okay, so what is the observation? So again, Br2 in water is also reddish brown in color. And then after the addition, it is no longer Br2. So what you will observe is reddish brown color of bromine decolorizes. Okay, because it's no longer Br2. So now, shall we move on to look at how we can use these 3 chemical tests, Bayes test, bromine test, and test with bromine water, to differentiate between cyclohexene and also hexane. Okay, so cyclohexene and also hexane. Okay, so cyclohexene, I think this is cyclohexane. Okay, so shall we change to cyclohexane? So cyclohexene, so 6 carbon. So this is cyclohexene. So cyclohexane is this. Okay, so if they ask you to give a chemical test, so what do we need? So first, we need to give the name for the chemical test. So what is the name for this chemical test? So among these 3, we can choose one. Okay, so for example, Madam choose Bayes test. So to answer this question, so first we write the name of the chemical test, Bayer's test. So here is 1 mark. Okay, so and then we need to write the equation. So for both, so for cyclohexene, so this is our cyclohexene, react with, so Bayer test, remember Bayer test, the reagent is KMnO4. And then what is the condition? Must be alkaline condition and cold. And what happened is, so this is having not too harsh, so will not break the carbon-carbon double bond, but will cause the double bond become single bond. And then OH added in, so giving you diol. And the KMnO4, it will be reduced to give you MnO2. Okay, and then what is the observation? So for KMnO4, it is purple in color after the reaction. So the purple color of KMnO4 decolorizes. And then, of course, you will get the brown precipitate of MnO2 forms. So this is for cyclohexene. You also need to write the same equation for cyclohexane. So cyclohexane, so KMnO4, so this is Bayer test. So Bayer test, reagent must sama. Reagent and the condition must be the same. So also you use KMnO4 in alkaline condition and then cold. Okay, double bond. If no carbon-carbon double bond, means that the KMnO4 cannot added into, okay, so cannot added into the carbon-carbon double bond. There's no carbon-carbon double bond. So means that you will not see any reaction happening. So if you can't see any reaction happening, then what you should write in the equation is no observable change. Okay, so if no observable change, so means that the observation, so the KMnO4 cannot react with the cyclohexane, so means that it will still be purple color. So the observation is the purple color of KMnO4 remains unchanged. Okay, so remain unchanged. So again, if they ask you to give chemical test, so what do you need? You need to first write the chemical, give the chemical test. So give the name for the chemical test. Okay, and then you need to write the equation. So second, you need the equation for both compound, cyclohexane and cyclohexene. So for both compound. And then you must have the reagent. And condition. You want to differentiate them, the reagent that you use and the condition that you use must be the same. Okay, and then don't forget, you also need to include the observation for both observations for both. So you want to differentiate them. One must give you positive result. One must give you negative result. Then only you can differentiate them. So in equation, if no reaction, you don't write no reaction, you write no observable change. You write no observable change. Okay? So shall we look at another example? So want to differentiate between propane and propene. So propane, alkane, propene, alkene. So how can we differentiate them? Reyes test, bromine test with bromine water. So you can choose one. Okay, so choose one. So like for example, for this one, I choose test with bromine water. So the chemical test, I write test with bromine water. Okay, and propene. So write for propane first. So if bromine water, my reagent is bromine, the solvent is water. So this is alkane. So we know that alkane, okay, so alkane, remember alkane, if want to react with bromine, okay, it cannot be water, okay, it need to be inert solvent and also must have presence of UV. But for this one, there is no UV light or heating. Okay, so if no UV light, no heating, so it will not react with bromine. So we write no observable change. Okay, we write no observable change. So if no observable change, that means that the Br2 masih lagi reddish brown color. Okay, so how do we write the observation? So we write, so the reddish brown color of bromine remains unchanged. Then how about propene? So propene, again, this is carbon-carbon types of reaction. So addition bermasuk carbon-carbon double bond become single bond, ikut Markovnikov's rule. So the bromine atom will be added into carbon which has more hydrogen. So this carbon, 2 hydrogen. This carbon, 1 hydrogen. So which one has more hydrogen? This carbon. So here Br. Okay. So and then water. So remember, after adding Br, this carbon become positively charged. So the partially negative side of water will come in. So this is the product, and the byproduct is actually HBr. Okay, so it's actually HBr. So observation, you see no longer Br2. So after the reaction, no longer Br2, so means that no longer having the reddish brown color. So reddish brown color of bromine decolorizes. So That is unsaturation test. Okay, so unsaturation test. So 3 unsaturation tests untuk bezakan alkene with other classes of compound. Okay, so to differentiate alkene with other classes of compound. So to summarize what I taught you tonight, okay, so alkene. So alkene. Okay. So to summarize what I taught you tonight, so shall we have an alkene? Okay, so maybe propene. Okay, so what I taught you tonight, so alkene undergo electrophilic addition. Okay, so it can undergo electrophilic addition with hydrogen, with the presence of catalyst, for example, platinum. Okay, so what will happen is carbon-carbon double bond. So this is addition, so it will become single bond. So CH3, CH, so CH2, so become single bond, and this hydrogen setiap atom on each side. Okay, so yang ini, because the electrophile is hydrogen, therefore it is being called as hydrogenation. Okay, and then the second I taught you is so hydrogenation. So hydrogenation can be in inert solvent and also in water. Okay, so for example, so in inert solvent, example of inert solvent like chloromethane. So what will happen? Again, it is addition. So double bond becomes single bond. Okay, so becomes single bond. So inert solvent tidak akan mempengaruhi produk. So bromine will be added satu atom on each of the carbon atom. So this is, so the electrophile is bromine. That's why called halogenation or bromination. And this is in inert solvent. Okay, and halogenation can also water. So water is not inert solvent, akan mempengaruhi the product. So but it is still addition type of reaction. So addition type of reaction di mana carbon double bond become single bond akan mempengaruhi produk. So the product is determined by Markovnikov's rule. Markovnikov kata halogen atom, satu je atom, will go to the carbon which has more hydrogen. So this carbon 2 hydrogen, this carbon only 1 hydrogen. So this one more, so bromine will come here, and then water, the OH will come here. So this is the halogenation in aqueous solvent or water. Okay, so or in aqueous solution. Okay, so product follow Markovnikov's rule. And then we also look at hydrohalogenation. Hydrohalogenation. For example, HBr. Okay, so still hydrohalogenation is addition type of reaction. So double bond become single bond. Equal Markovnikov's rule. Hydrogen need to add it to the carbon which has more hydrogen. More hydrogen. And Br on another side. So this is hydrohalogenation. So follow Markovnikov rule. Okay, so this one also follow Markovnikov rule. Okay, Markovnikov rules. Okay, so and then addition sometimes can be anti-Markovnikov kalau there is a presence of peroxide. So this one peroxide, so anti-Markovnikov. So but it is still addition. It is still additions type of reaction. So means that double bond masih lagi become single bond. Double bond still become single bond. Tapi with the presence of peroxide now become anti-Markovnikov. Anti-Markovnikov. So hydrogen need to go to carbon yang kurang hydrogen. So another side Br. So this is still hydrohalogenation. But then at the peroxide, so anti-Markovnikov. Okay, so and the last one of electrophilic addition is hydration. Remember, you add acidified water. So this H3O plus is the catalyst. Okay, so this one also follow Markovnikov. Follow Markovnikov. Hydrogen go to carbon with more hydrogen. Okay, so again, this is addition. Carbon-carbon double bond becomes single bond. And follow Markovnikov, hydrogen go to carbon yang banyak hydrogen, so OH. So this is the product. Again, this is hydration. And this follow Markovnikov. Okay, and then if you look at it carefully, you will realize that this is your bromine test. And this is the test with, I should draw like this. So this is the bromine test. Okay, and this is the test with bromine water, the unsaturation test. Okay, so that is electrophilic addition. And then beside electrophilic addition, so tonight we also seen that our alkene can undergo another type of reaction which is called oxidative cleavage. Okay, so for oxidative cleavage, okay, so can use two type of reagent. So the first one is ozone. So ozone, two-step. Okay, so two-step. So zinc, water. So what happened when using ozone to do oxidative cleavage, we basically break the carbon-carbon double bond. We break the carbon-carbon double bond, and then we oxidize it. So we get two products. This is ozonolysis because we use ozone to do the oxidative cleavage. Okay, and then for oxidative cleavage, we can use harsher oxidizing agent. We can use hot acidified. So hot acidified KMnO4. So if hot acidified KMnO4, we also break the carbon-carbon double bond, but harsher. So we get, can you see this part? After break, we get aldehyde. Remember, this is strong oxidizing agent, will not stop at aldehyde. It will further oxidize to become carboxylic acid. And then this is terminal. So this is terminal carbon-carbon double bond. So CH2, so the CH2 will be oxidized to give you carbon dioxide and water. Okay, so that is the oxidative cleavage using KMnO4, hot acidified KMnO4. And then we also look at the unsaturation test. So the bromine test and also the test with bromine water basically is electrophilic additions reaction. And there's another one that we have seen is Bayer's test. So Bayer's test, we use KMnO4, but then in milder condition. So in alkaline, cold condition. And what will happen is, so the carbon-carbon double bond will break, become single bond with OH added. So this is what you learn in Form 5. You get diol. Okay, so this is Bayer's test. So this is the mind map of what I taught you tonight. So the summary of all the things that I taught you tonight. Okay, so this mind map is very important for you to revise your chemistry. Okay, so because organic chemistry later on, next chapter and the next chapters, you are going to see a lot of reaction. So mind map is important for you to summarize all the reaction. Okay, and then for tonight class, you can do homework. So in the mastery practice, you can do question number 7. I don't want to write this page. So I don't want to write this page. Okay, so you can scan and then key in your attendance. Okay, so for homework, you can do mastery practice question number 7. Question number 8 you can't do yet. Question number 9. So you can do question number 9. Question number 10. Question number 11. Question number 12. Question number 13. So you can do all those questions. So now you can scan the QR code to key in your attendance. Okay, so I give you 3 minutes to key in your attendance, and then I'm going to finish the class for tonight. So any question? Any question? So while you key in your QR code, so any question you would like to ask me, I can see your chat. So you just key in your question in the chat, live chat. So any question you would like to ask me? Class, any questions? So if yes, then you can put in the live chat. So if no, then okay, 2 more minutes. Any question, class? So if no question, then for the QR code, I will give you 30 minutes. Okay, so after 30 minutes, I'm going to close the form. So I will assume you do not attend my class tonight. Okay, so if no question, then good night, everyone. I will see some of you tomorrow. So bye bye, good night.